Have you ever wondered how an electronic switch can remain turned on, even after its trigger signal has been completely removed? It is a fascinating characteristic found in certain semiconductor devices, crucial for many power control applications. The latching current in a Silicon Controlled Rectifier, or SCR, is primarily influenced by several key factors including the junction temperature, the gate current's pulse width, the gate circuit's impedance, and the rate of rise of the anode current, also known as di/dt. Understanding these elements is essential for reliable circuit design. The latching current is the minimum anode current required for an SCR to remain in its on state immediately after the gate trigger signal is removed. If the anode current falls below this threshold during the turn-on phase, the SCR will not fully latch and will revert to its off state. Junction temperature plays a significant role because higher temperatures increase the internal carrier generation, making the SCR easier to turn on and thus potentially lowering the required latching current. Conversely, at lower temperatures, more anode current might be needed for proper latching. The gate current's pulse width and amplitude are critical because they determine the amount of charge injected into the SCR's gate region. A wider or stronger gate pulse provides more charge, ensuring a more robust turn-on and requiring a lower latching current. If the gate pulse is too narrow or weak, the internal regenerative process might not fully develop before the gate signal is removed, demanding a higher anode current to sustain the on state. Additionally, the impedance of the gate circuit affects how effectively this charge is delivered, with lower impedance allowing for a quicker and more effective turn-on. The rate of rise of the anode current, or di/dt, also impacts latching. If the anode current rises too slowly, the internal regeneration process might not build up quickly enough to sustain conduction, potentially leading to a higher latching current requirement. Manufacturers rigorously characterize their SCR devices across various operating conditions and provide detailed data sheets. These data sheets specify typical and maximum latching current values, which are critical for engineers to consult during component selection. To ensure proper SCR operation, always consider these factors during the design phase. You can select SCR devices with appropriate latching current specifications for your intended operating temperatures and gate drive characteristics. Implementing gate drive circuits that provide sufficient pulse width and amplitude is also crucial, along with ensuring the anode current rises quickly enough to meet the device's latching requirements. Remember, latching current is distinct from holding current. While latching current refers to the minimum anode current needed to turn on an SCR, holding current is the minimum anode current required to keep an already conducting SCR in the on state. This distinction is vital for understanding the full operational characteristics of these powerful semiconductor switches, allowing you to design systems that are both efficient and reliable. By carefully accounting for the interplay between temperature, gate drive, and current dynamics, you can confidently select and utilize SCR devices. This proactive approach helps prevent unexpected turn-off issues and ensures your power control circuits operate exactly as intended, providing robust and predictable performance in diverse applications.